Hi, welcome back. In this video, we're going to talk about the things that affect your cold starts, which in a nutshell are the frequency and duration of cold starts. Unless you're calling your function via a cron job, the frequency of cold starts is going to be driven by some kind of user traffic. If there's a spike in traffic, then Lambda is going to auto-scale the number of containers it runs your function on, and you'll see cold starts. In general, there's not much you can do about these cold starts. The so-called Lambda warmers are also highly ineffective once you have more than one concurrent executions. Amazon announced a new feature called provisioned concurrency, which is basically the EC2 auto-scaling for Lambda. It's the only tool you have to minimize the frequency of cold starts. I wrote about it in the blog post here, which covers how it works, the caveats to keep in mind. We're going to cover provisioned concurrency and when you should use it later in this chapter. For now, just remember that you shouldn't use provisioned concurrency as default and see it as a last resort for when your cold start duration is so bad that you basically cannot tolerate any cold starts at all. And cold start duration is where we should be focusing our efforts on optimizing for better cold start performance. You've probably seen this diagram before. That shows you the different life cycle stages of an invocation request and what happens during a cold start. Notice that the first half of the steps are all AWS. We can't do anything about that. But that's also a good thing, as AWS has been working hard to improve things on their end, and some independent research shows that cold starts are getting better across the board without us having to do anything ourselves, which is the best kind of automation. And the only thing we can do to optimize the cold start duration on our side is how long it takes to bootstrap and initialize our code, which you can see in the logs for your function. The report log message for a cold start will always report the init duration. And if you enable X-ray tracing for your function, then you can also see it in the trace for a cold start, which includes this segment called initialization. And you have the same value as what you see in CloudWatch logs. But that just shows you what happened on a single invocation on a single function. To get a more holistic view of the init duration for all of your functions in all the regions, the Lumigo CLI we saw in the last lesson has a command to help you analyze Lambda cold starts. So let's switch to the console to see how it works. Alright, so in this project I have 3 different functions set up. One that has no dependencies whatsoever, not even the AWS SDK. Another one that requires the AWS SDK but doesn't actually use it for anything. And another function that just requires the DynamoDB client from the AWS SDK without requiring the whole AWS SDK. So all 3 has been deployed, and I have used the step function to trigger 1,000 cold starts on each of these functions. And now what I can do is I can use the Lumigo CLI, and I can say -help to see all the different commands, and the one we're looking for is the analyze Lambda cold starts. So I can go Lumigo CLI, analyze Lambda cold starts. And by default, it's going to look for cold start information from the last hour, but we can override the behavior by specifying number of days or number of hours. Or we can say only analyze functions in a particular region. In this case, I can say I'm only interested in the US East 1 region, and please find me cold starts that happened in the last 6 hours. In the background, it's going to analyze the report log messages for all the functions in US East 1. And from this table, you can see the function name, runtime, memory allocation, how many cold starts, the median init duration, and the max init duration. And if you have configured provision concurrency, what is the total provision concurrency for this function? And what is the utilization level for that provision concurrency, which for now, I don't have any configured in this region. And if we go down to the bottom here, for the function that has no AWS SDK, you can see the median init duration is about 120 milliseconds, the max is 237, and the function that requires just the DynamoDB client is 236 for the median and 387 for the max. But the function that requires the full AWS SDK has a median init duration of 378 milliseconds and over 623 milliseconds for the max init duration. what you should take away from this is that the more dependency that you bring into your function, the higher init duration and therefore cold start duration you're going to experience from your function. We're going to look at how we can improve this significantly later in the chapter, but for now, just know that you can use the Lumigo CLI to analyze the cold start performance and behavior for all of your functions in all the regions. I will see you in the next lesson.